Okay, now we come to the combined gas law. Okay, just recap a little bit, right? Okay, combined gas law is something that you get, okay, when you combine the Boyle's law and the Charles law together. So in that case, what I get is actually an equation P1 V1 over T1 equals to P2 V2 over T2. Okay, this is the consequence of the combined gas law. All right. Yeah. Okay. So here, right, I have got a pressure that exerted on 1 dm cube. Okay, sorry, calculate the pressure that must be exerted to 1 dm cube of a gas. Okay, measured 1 atm and minus 20 degrees Celsius in order to compress it to 0.5 dm cube at a temperature of 40 degrees Celsius. Alright, now, so let's quickly try to identify what is the P1, V1, T1, okay, and what are the other rest of the variable. Okay, the 1 dm cube gas is actually the initial volume of the gas, okay, measured at 1 atm, so this is the P1, at negative 20 degrees Celsius, so this is the T1. Then compress it to another volume, the new volume, 0.5 dm cube, and then another pressure 40 degrees Celsius, so this one will be T2. Okay, yeah. So okay, like I say, right, people, again, you see if I were to rearrange this equation, right, okay, yeah, it will be like a ratio thing. So what do I want to calculate here? I want to calculate P2, right? Okay, so I show you, okay, I want to calculate P2. So make P2 the subject. If I make P2 the subject, what will I get? I will get T1, okay, times V1 over, times P1 times V1 times T2 over V2 times T1. Okay. Now again, you see that there is the volume. Okay. On top will cancel out with the units for the volume will cancel out. The temperature will also be cancel out the temperature unit. But why? Okay. But I want to emphasize what I said in the Charles law part. Okay, now it is always very important for you to convert the degrees Celsius to Kelvin. Okay, okay, if you don't convert, right, okay, let's say I just bring apart T2 over T1. If you do in the degrees Celsius, right, okay, what you will get? You will get T2 is 40, then over negative 20, which I get negative 2. Okay, but if you convert to Kelvin, okay, it's an entirely different answer. Okay, 253, sorry, it's 313 over 253. So you cannot use Celsius 1. Okay, Celsius will give you an absurd answer. Okay, it will give you a very entirely different answer. So all this computational thing, okay, for temperature we have to use Kelvin. Okay, we have to use Kelvin. Okay. So right now the volume, okay, volume is that I need to convert, no need to convert anything because the volume, okay, will just cancel out by itself. Okay, so why is it that you cannot like take the Celsius, okay, to divide? Is also because you see when you convert between Celsius and the Kelvin, right, there is a plus 273 factor. Okay, yeah, so you cannot, when you do any ratio thing, right, any calculation involving ratio, like something, let's say temperature 2 divided by temperature 1, there is an addition factor here, so you cannot, okay, you cannot do the cancellation. Okay, but for other cases like the volume and pressure, no issue one, you can always keep the volume stated in the, keep the units for the volume and the pressure in the question, because they will cancel out. Okay, like in this case, right, V1 dm cube, okay, V2 also dm cube, right? So the dm cubes will cancel out each other. So this one is not an issue. Okay, so this one, okay, quite simple. Once you convert the temperature to the right unit Kelvin, after that, make sure you plug in correctly to the P1 V1 over T1 thing. Okay, then after that, you will be able to get P2 as 2.47 atm. Okay, so just need you to be careful of the units in temperature. Must convert to Kelvin. Okay, must convert to Kelvin. So that's it for the combined gas law.